I'm Peter Stojcsics, and I have been working with Emarsys in the last 5 years. I'm VP of Engineering, and with that title, it comes that I'm leading and representing the engineering organization and the product development processes as well. Today, I'm going to share a few insights about Emarsys and the practices that made us succeed. But before we do that, you have to know that Emarsys is a software as a service company. We have an AI-powered marketing platform, and this platform, it serves a lot of customers. It processes a lot of data, and in fact, the numbers you can see on this slide are already outdated. I actually made them a year ago, and since then, we grew a lot. But even that time, a year ago, we got more than 30,000 inbound events every second to our system. So when someone opened an email or a customer updated some contact data, we have that in our data platform. And in our data platform, based on that data, we make 3 million calculations every single second. Also, we make 5,000 decisions every second for our automated marketing campaigns using this data. And this results in a lot of messages we send. Just to put it in numbers, for example, last Black Friday, which this year we are also getting closer and closer, in a single day, we sent out more than 1 billion messages without downtime or any major issue. I'm also giving you a little bit of overview of our technology. So technology-wise, we have a mixed platform. We have private cloud with 4 different data centers, 4 different physical locations, 2 in Vienna, 2 in the US. And we also have a large cloud footprint, mainly in the Google application platform. We mainly use our private cloud for the main application, which is the oldest monolith. We not yet factored out to microservices, but in the last 6 years, we followed a cloud-first approach, and that means that new features and new services born in a microservice architecture, and these services were deployed to GCP, Google's cloud platform. At the end of the day, we have more than 700 physical servers also in our data centers, and in the 2 platforms combined, we have more than 400 microservices in production. If you add staging and then development environments, it's more than 1,000 different microservices that we have. And lastly, we are also working on a petabyte scale data. We mainly use Google BigQuery, Google Bigtable on the Google Cloud. We also use MySQL, PostgreSQL, MongoDB, and a lot of these different technologies that you will also see in my other slides. But with such numbers and such technological diversity, we could be in trouble without good practices. But our practices served us well, especially the constant requirement of continuous delivery. It really enforced us to build a really resilient system. One easy example is that last year, only in a few months, we managed to move more than 500 microservices from Heroku, our previous application platform, to GCP, to our new Kubernetes-based application platform. So you can imagine that's a huge infrastructure to build and to operate as well. I'm also giving you a little bit sneak peek into the technologies that we use on the tools wise. For version control system, we use Git. We have more than 1,600 repositories. On the backend side, we use PHP for microservices. We also use Node.js for microservices, as well as Java, Scala, Ruby, Python, R, even Go, even Kotlin. On the CI, we use CodeShip as a cloud provider for our pipelines, but we also have TeamCity, we also have Jenkins, and we also started adopting GitHub Actions. With those, we have more than 600 pipelines, more than 300,000 tests. That escalates to a very good code coverage. And then also, we deploy to production at least once per day, but I can also say we have days where we deploy to production 50 times a day. On the front-end side, We use JavaScript, TypeScript, mainly with Angular and Vue.js frameworks. But we also have our own component collection, which we call Emarsys Design System. Right, let's go into how we work. So imagine agile software development is usually presented with a similar figure. It's an iterative way of working. It has a larger cycle for the releases that we do every 3 months, but it's more of a marketing release. It's not really about the CI/CD. On the other hand, there is like an inner circle that we do for daily development and operations, and also the continuous delivery of features into production environments every hour or less. We pick the extreme programming as our guide to form our processes and mindset. And I'm going to give you a little bit story about how we ended up with extreme programming. It's a funny story. So 11 years ago, that was before Emarsys was not even a thing. The founders of our R&D department were preparing for an audit. They had to write about the development methodology to pass the audit. So they looked around in their previous company, looked on the bookshelf, and they found this book called Art of Agile. How that Art of Agile book ended up there, I mean, we will never know. But the book was about XP, extreme programming. They thought that this name is funny enough to form the audit. But unfortunately, they also read it. And they concluded that it is amazing, especially compared to the last 10 years of doing waterfall development. So they said, let's try it out. So they left their job, partnered up with some guy from Israel, who were trying to find developers who are brave enough to tidy up and improve a legacy, but business-wise really, really promising software. A real monolith they struggled with. So this is when and how Emarsys R&D was found, based on the XP from the very beginning, propagating Agile from the top. They really faced a huge challenge. They got a 10 years old code base, a real Death Star for all you Star Trek ones, with a lot of unnecessary functionality in PHP, without any automated tests, failing on every single deployment with a questionable code quality. You can imagine that it takes a lot of courage to deal with that challenge. But XP, this is where we started. And XP made us survive. Helped us to stabilize this monolith, improve it, slowly cut out features, and develop new ones in microservice-oriented architecture. And I really think that XP is a very underrated Agile methodology. It's not Scrum, it's not Kanban, it's more of those. It's a superset of them. It's a full-stack development culture with a mindset for product development. Today, I'm not going to explain all the values, principles, practices that we use and XP makes us use, but I would like to highlight like some of them. It's also important to mention that we work in these dual track Agile development cycles. That means that we have a discovery and a development phase. On the discovery phase, there is a problem discovery, which is made by the discovery squad. The ownership is at the project managers, but developers, UX, and data scientists are also involved at that time. It's mainly about coming up with a problem, which if we can solve, can make us a lot of money. And when we identify that problem, we are going into the solution discovery. Now, the solution discovery is a joint effort together with the PMs and the developers, bringing in UX and data as well. But really, this is the time when the team is coming up with a plan, coming up with a backlog full of stories on how we can solve the problem. When we have that, then comes the first iteration with the iteration planning. This is mainly done by the developers, obviously involving the UX and the PM as well. They do the iteration planning, they plan weekly iterations. Inside the weekly iteration, they implement the stories that were planned into the actual sprint. They finish those stories, and by finishing them, that means finishing. The definition of them is also there. So every single finished story is actually done by the definition of them. And our definition of them is important because it includes putting the code in production. Putting the code in production, sometimes it's not easy. But it's easy for us because we do it in that way that we are really doing continuous integration. So all those commits that our developers do, they are pushed to the repositories, and each of these pushes, it triggers a build and test. And if all the automated tests are running, everything is green, everything is okay, then an automatic deployment to the staging environment is there. After the automated deployment of the staging environments, we can also do some other checks, even check it manually if you would like to. Our developers can log in, can play with the UI, can run the jobs. But then the developers are also empowered to decide that, well, it's good enough, it's time for a production deployment. From there, they can say that, okay, I'm deploying that stuff into the production, and it can be in production in minutes. In minutes from starting to write the code. That's really, really powerful. We do that with the single branch policy and the feature switches. It helps us because if we use only a single branch, that means that we don't have to deal with all of these merges. We don't have to deal with all of these feature branches, which are missing features, which are not even running, and all of this headache we don't care about. We work on a single branch, we put the new developments under condition. These conditions can be really easily switched with feature switches. We also call them flippers because it's like really like, playing with a flipper. And that's good because we always work on the most recent version of the system. We always being able to commit and deploy the code into the production without the fear of breaking something for our customers. Because we can use these feature switches to turn these new features or this changed functionality for our customers on and off. We can turn it on for 1 customer, or for 5 customers, or for whole environments. It is a really powerful tool that we have there. Right. We also have this team autonomy. You can guess what does it mean, but really it's like our teams are usually presented with a problem and not with a solution. They are presented with a problem, they can come up with a solution. They can come up with a solution of how they would like to solve this business problem. They can choose their own programming language, they can choose their own monitoring tool, their own platform. They can make their own technical decisions. And it's important because with that, they have great autonomy, they have great ownership. That's needed for DevOps. Right, time is running, so I'm going to continue. We also work with TDD and pair programming. We really believe in face-to-face work, pair work, because the addition of 2 developers, it's like 1 + 1 = 3. It's great because we don't have to do boring code reviews, because every single line of production code is already made by 2 developers, which is also means already reviewed by 2 developers. It's also a great way to socialize, to improve juniors, to strengthen relationships, and to onboard people to the team. We also take this test-first approach. So we always start with high-level functional tests, then continue with integration tests, and then unit tests. This is really the best way we go. We learn that. But we also move fast. And we move fast because we take more risks. And let's finish this with the attitude of taking risks, because it really allowed us to move fast. We take the risk with the simplicity. We try out things, methods, ideas, experiment with them without a huge planning or reporting. We don't consider too much value on centralizing or generalizing things, complicating without a measurable value or reason. This way, we can keep innovating, improving, breaking down dependencies, and avoid the complexity overall. We really push all of this autonomy and decision-making to the bottom, to the development teams. They are responsible for their processes, tools, ceremonies, programming languages, services, innovations, and so on. It gives them the ownership and the opportunity to improve on the spot. Each team and project are very, very different. The only common thing is the mindset, the values, and obviously some compliance requirements. That was our brief introduction to our development culture. You could feel that we just exaggerated what we are doing, and we might hide some mistakes we made. But it's not the case. Though we really like to talk about our successes, we can see our weaknesses as well. So what I have just told you doesn't mean that everything shines and we have no problems or incidents. In fact, we had more than 200 postmortems in the last 2 years. These postmortems were organized by the development teams themselves. And this is the attitude of continuous improvements that ensure that we have pretty good feedback about our processes, customers, user experience, and system stability. That's how Emarsys works today. Thank you for listening. If you have questions, this is the time to ask them.